Please welcome Senior Vice President of Security Products, VMware, Tom Korn.
Great, thank you. Welcome, everybody. Welcome, thanks for taking time out of your afternoon to come see a presentation on security. What I'm going to cover over the course of the next, say, 45 minutes is kind of walk you through our view of the security space, of the security issues, our vision here, our direction, our strategy, some of the things that we're doing right now, and some of the things that are coming next. So hopefully, as I said this morning on the keynote, hopefully this provides in a short space of time a single sort of picture. And then there's a whole bunch of really interesting, compelling sessions going on over the course of the remaining days where you can dive deeper in specific areas. But what I'd like to begin with is taking a look at, as we look over the course of the history of not just cybersecurity, but warfare in general, there's a series of recurring financial patterns of sort of cost-effectiveness curves. Now, in each of these patterns that you see on the slide, there's always an increase in cost over time, an increase in spend over time. But one pattern you see is the arms race pattern, where you're investing in a series of defenses, an attacker then modifies, invents, innovates, invests in a new area, your effectiveness goes down, you then respond, your effectiveness goes up, and you have this back and forth. If you take a slightly wider time horizon, you see this second pattern, which is the diminishing returns pattern, where you invest in a particular area, and over time, increased investment doesn't yield a corresponding increase in effectiveness. Today, we see that in a number of sort of for example, the signature-based AV technologies, where you just see diminishing returns of deploying some of that technology. The last one you see in a slightly wider time horizon, which is a period where it doesn't matter how much you invest, you see a drop-off and a pretty substantial drop-off in effectiveness of defenses or any increased investment in defenses. This often happens when the whole battlefield changes. And what occurs is it becomes very, very difficult to align your forces against what you're protecting. And as a result, it doesn't matter how much you're spending or even innovating around it. If you can't align it to what it's protecting, you end up in that kind of situation. And we've seen this pattern many times over the course of history. And one of the earliest methods of alignment is the castle wall. And this dates back, we have some walled cities going back 14,000, 15,000 years into areas of sort of what are now southwest Turkey. The wall itself provided a means of aligning defenses around some structure. And once we had that in place, we had thousands of years of innovation in the kinds of defense mechanisms. For example, the rounded turrets was an innovation to be able to deflect projectiles coming up against the castle walls, much better than actually a flat-walled surface, as an example. And so there was a series of innovations that happened in the kinds of weaponry and kinds of defenses, but the fundamental structure provided the means of aligning. Of course, then the world changed. And the world changed as the feudal system dissipated and populations from walled cities ended up moving out into the countryside. And at that point, we really didn't have a way of aligning forces against that until we started to innovate around the notion of a standing army. And once we had this notion of a standing army, we had many years of innovation around it. The Romans innovated quite substantially in this. They innovated with everything from formations of a standing army to tactics to even battlefield surgery. We see this pattern over and over again. Another example of this is in World War II, where we started to use aerial warfare. Now, we had airplanes in battles prior to that, including in World War I, but planes were largely relegated to espionage and providing reconnaissance. In World War II, that changed, and we started to use airplanes as a means of attacking and defending a position. And what that did is it changed it from a two-dimensional battlefield to a three-dimensional battlefield. Now, at this scenario, it doesn't matter how much you're investing and innovating in terms of defense mechanisms for trench warfare. You're in trouble if you can't figure out a new way of aligning to how the battlefield has changed. We had a similar battlefield change a number of years later in the Vietnam War, where helicopters were used and really changed the game in troop mobility. Suddenly, you didn't have to deal with a particular front. your front could be a time and place of your choosing. And it changed warfare quite substantially. And then more recently, of course, we see it with urban warfare, right? In urban warfare, the fact that you have a large army, the fact that you have sort of large substantial weaponry doesn't make as much of a difference if you can't figure out how to realign your defenses and realign your forces in accordance with this new battlefield. So what does our battlefield look like? I mean, I would argue in a traditional data center, our battlefield looks a lot like a walled city. Inside that walled city, we have people conducting business. You have suppliers and vendors and bankers and all interacting through a series of processes where they're going back and forth, and they're using the infrastructure of our walled city in order to conduct that business. They're conducting it inside buildings, which might be akin to the servers in our environment, and they're connected together by a road system, and there are many paths to take between two of these things. And if you think of how you'd try to protect these series of processes in commerce, it's a complicated question, particularly since the defenses are largely deployed right here on the ingress-egress point of our walled city. Now, of course, we're not dealing with people in buildings and road systems. Our infrastructure are servers and networks and storage, on top of which there's a management layer, and on top of that we have an application infrastructure, right? And plugged into that, our defenses have really aligned with that. We have created an entire industry, and we spend roughly $30 billion a year on the infrastructure laid out on this slide. We have various forms of endpoint security and anti-malware on our compute infrastructure. We have next-gen firewalls, web application firewalls, intrusion detection and prevention systems on our network. We have encryption and tokenization on our storage. At the top here, we have application controls as well as identity controls like authentication, authorization, and the overall identity and access management. And we even have a management layer to our security infrastructure, including governance, risk, and compliance, the tools that allow us to translate from our policies to how you set up infrastructure, or correlation and analytics, tools used by security operations teams to detect, investigate, and respond to attacks that circumvent our perimeter. But our policies, our fundamental policies, aren't about servers or network or storage. They're about people and applications and data. They're formed in as who should have access to certain critical applications, certain transactions, certain information. Now we need to translate these policies into how they're implemented at the application tier, but also implemented at the infrastructure layer. That's where the problem occurs. Because when you try to implement this at the infrastructure layer, historically that layer, which is compute, network, storage, that layer in the early days of computers, in the mainframe era, in the early client-server era, was a monolithic stack. So if you tried to implement that policy or implement a control in the compute infrastructure or the network infrastructure, or on your storage, it had a natural alignment to the application it was trying to protect or the data that it was trying to protect. But then the world changed. And the application ceased to be an executable on some monolithic stack. It became a network. It became multi-tiered distributed architecture applications, composed services. These are multiple components on different compute infrastructures networked together, commingled on a common shared infrastructure. And so that same challenge of how do I now implement those particular controls aligned to the application became very, very difficult to do. And attackers take advantage of that. They take advantage by finding a relatively porous perimeter, which we really almost have to by the very nature of how business is conducted together. But once inside, have the means in a hyper-connected computing base to propagate through the infrastructure to be able to get at what they're ultimately trying to get at. And we see this replicated over and over in what is depicted here, a modern kill chain. For those of you not familiar, it is simply step, the process that an attacker goes through in conducting a modern attack. And I have had the fortune or misfortune of living through one of these during my days at RSA. If you recall, in March of 2011, RSA had a massive state-sponsored attack breaching in, and it followed very similar to this kind of pattern, right? You pick an objective, you then need to do a whole series of reconnaissance to figure out who are the right people who have access in that environment to the systems and the data that you need. Worst place to look for that is an org chart. I can't make heads or tails of who does what in VMware from our org charts. Great place to go is LinkedIn and Facebook, because people will tell you exactly what their responsibilities are and exactly what systems they have access to. From that, you need some means, you need some piece of malware to be able to take control of their system. And clearly this has to get more and more sophisticated, but the weaponization of cyberspace has made that increasingly easier, because I have toolkits, Zeus, Black POS. I mean, these are now really only a few $1,000s, and that includes customer support. I have 800 lines to help me if I have issues in sort of creating new malware. And it's certainly easy enough to test this against any endpoint security that exists. I certainly wouldn't send something out that I hadn't QA'd. So the notion of creating malware that can take control of a system that is going to pass through any endpoint security control has really been sort of trivialized at this point. I need the means of getting it onto those systems, and there's a whole variety of techniques that are used, including everything from spear phishing, so creating customized phishing attacks on individuals, to water holing, where you compromise common infrastructure like local schools in areas, communities where you have a large population of employees. Increasingly common is the supply-side attack, and that's the type of attack that was done on RSA. It's the kind of attack that was done on Target, et cetera, where you go after a weak supplier. For RSA, it was going after an HR contractor in Asia. With Target, it was an HVAC vendor, I believe. And you basically go after that supplier and use their connection into the organization, right? Then you really are going through the propagation. What I'm installing on your infrastructure is a command and control infrastructure, which allows me to see things and control things on that. Right? I'm going to be communicating that over very common ports and protocols that are very difficult for you to detect. In fact, if I do my job right, the malware that I'm creating won't harm the performance of any of your systems. From that, I'm typically installing multiple strains, putting some strains to sleep, waking some strains up, propagating through your environment. I'll leverage your log infrastructure to give me some visibility into what connections are typically possible from that given endpoint. I'll move through that infrastructure, escalating privileges, lateral movement, escalating privileges, lateral movement. If you catch me, I'm totally cool with that, because I have visibility into the kinds of alerts I set off. The way you wipe me from your machine, now I wake up strain B, I adjust it so that it doesn't set off the same alert or get wiped in the same way, and that way I maintain persistence. Extraction and exfiltration are really the really trickiest stages of this, because at that point, I'm on your turf. First of all, I have to bounce around your environment. That's true about propagation as well. But if you're any sort of reasonably sophisticated organization, there is encryption, there are credentials to get into that, but that's really only a question of time. And fortunately, I have time, because you have very little visibility and control inside the east-west traffic of your data center. Most of your security controls are deployed at the edge. And that's the main point here. It's that of the $30 billion that are spent last year on security controls, we're still spending 80%, not just of our product spend, but also our human capital, on stopping infiltration. And too little of our investment is going on dealing with visibility and control inside our environments to detect the propagation, extraction, and exfiltration. And I think I brought this up on my talk last year, that this is a very asymmetric battle, to be sure, but it is far more asymmetric on intrusion than it is throughout the kill chain. In fact, it gets arguably increasingly symmetric as you move through that kill chain. In other words, on intrusion, as an attacker, I can try 1,000 times and I only have to succeed once. You have to succeed 1,000 times. But once I'm in your environment, arguably, I'm bumping around your house, which I don't know that you know, in the dark. And if you had the right visibility and you had the right controls, you should be able to spot that there is someone who's doing weird things in my house, bumping into walls, making noise. The point is we don't have that visibility. So why? If we all get it, if this is already cliche, why haven't we made that adjustment? And my thinking on this, our thinking on this, is because it's extraordinarily difficult to do that. It is extraordinarily difficult to take the security controls we already own and simply move them and deploy them inside our data centers. And it is difficult not because of a security feature or a security product, but for architectural reasons. That, in essence, having distributed, multi-tiered applications commingled on a common infrastructure creates massive misalignment issue. The battlefield has changed, and we are struggling to find ways to align our controls to what we're protecting. And it leverages the fact that in our data center, we have this hyper-connected computing base. We have a massive distributed policy problem as a result, and we also are forced to continually make a context isolation trade-off based on where we're placing security controls. And let me give examples of each. On the hyper-connected compute base, we tend to have fairly flat networks. When we do segment our environments, we segment based on physical sort of asset classifications, like my web servers, my app servers, my database servers, my storage servers, my DMZ, my application gateways, my application services, my backend services. Very logical. There are telemetry and handles that I have accessible to me. There are relevant security controls and certain things that only should work between an app tier and a web tier. But really, it does almost nothing for security. Lateral movement is not only easy, but easy to hide. And policy complexity shoots through the roof. And here's why. I just have to get into the weakest link in any one of these. I've commingled components from potentially hundreds of applications in any segment. If I'm able to get into just one, I have free reign within that segment. And here's the kicker. Any application between its tiers has a secure, authenticated path that I can move through. So once I get into one part of it in one tier, I can move through the application to the other tiers. To add insult to injury, if you try to stick a security control here and between any of these tiers, you now have hundreds, potentially thousands of applications on either side of that. And so the policy sets that go into that control end up having to take count of all of that application traffic. I have now seen firewalls fall over in environments not because of too much traffic, but because of too many rules on it. And when was the last time any of us have removed an ACL from a firewall? It's often very rare because it's very, very difficult to sort that out. Now, granted, there's a number of sort of the higher-end sort of firewall vendors, the checkpoints, the Palo Altos, et cetera, that have found more sophisticated tools to manage this. But this is clearly an issue on east-west traffic, right? There's also a distributed policy problem, right? And here's a way of thinking about this one. So I have, in a traditional model, I have typically a small set, single or small set of service chains of security controls on my north-south boundary. They're in a particular order. Order matters. Anyone who's tried to encrypt before DLP or anyone who's tried to put a load balancer before a web application firewall knows that order really does matter. It can really make a difference. But the policy sets for this tend to be coarse-grained. It's just focused on the traffic that's leaving or entering the data center, of course. But as you move security controls inside, where do you put them? There isn't a single road. There's many roads that connect this infrastructure together. Now, once you do this, once I have multiple instances of controls, multiple controls throughout the environment, now I have a series of problems. Here's one. As I move from one machine to another machine, I might hit multiple instances of a control. Make sense? I might hit multiple firewalls. Great. What's our firewall policy? Our firewall policy is now the combination of policies of every firewall that you hit in the order that you hit it. That starts becoming an intractably complicated problem. Here's another one. Distributed service chaining. In between this service and that service, I need a series of controls set up in a particular order. How do you do that, right? I am sharing a common infrastructure with a whole series of applications. How do I order the path and the route that the data goes through to go through a particular service chain? And by the way, I have lots of these. And last but not least is the ability to share state, the ability for one of those controls to pass what it has seen on to the rest of the controls, right? I have some vulnerability scanner that has spotted a on something, a CVE score of over 4. That would certainly be relevant context for the rest of the security controls. But we really don't have a means of sharing that state, save having two companies integrate their products together, which is not a scalable model. There isn't an external sort of state distribution mechanism. Right. All right. The last architectural issue is this context isolation trade-off, which is really saying, look, there's really only two places we largely place controls inside our environment. Control being sensor, something to detect things, something to physically control things. And that's the network or the endpoint. And there's a trade-off we make when we do that. When we place things on an endpoint, the endpoint has got very rich context, right? The endpoint is a great place to do security. The endpoint is a lousy place to do security. It's great because of all the context. I can see the app, the user. I can see, has someone changed the configuration? Has someone escalated privileges? All those very meaningful telemetry for policy and for analytics. But I lack isolation. I'm on the same trust domain as the attacker. And so it's very difficult to protect my position, which is in part why 3 or 4 times the amount of money are spent on network security than endpoint security. The problem on the network security is I got the isolation, I just don't have the context, which is why the entire next-gen firewall, for example, got developed in order to provide context to the firewall so that it could understand the user and the application. That's great. But it's not just the firewalls that need that. It's all kinds of security controls that need that context. And internally, with thousands of custom applications and an order of magnitude more traffic than on the north-south perimeter, this becomes a growing challenge. So, context isolation trade-off, this distributed policy problem, this segmentation issue, this hyper-connected compute-based issue, are the architectural reasons that make it incredibly difficult to align our controls, especially when you commingle many multi-tiered applications on a common infrastructure. So here's the answer. Are you ready? The answer is build a different data center for every one of your applications. It will work. If you build a different data center for each of your applications, you solve many of the issues I've just described, right? Lateral movement is not as much of an issue. I can break into different data centers, but it's less a lateral move than it is a new break-in. I have a natural segmentation around it, which not only provides a barrier between these, but I also have a means of aligning my defenses, of aligning my controls around it. It's my walled city. The context issue is, in many ways, taken care of because I'm only dealing with one application, right? I don't have the distributed policy problem, right? Essentially, my perimeter has now been the single service chain I need to be able to deal with. I can now segment my web tier and my app tier, but I haven't commingled within that segment multiple applications. It does suffer from the minor issue that it would cost roughly the gross domestic product of a small European nation to implement. But other than that, it's a pretty good solution. So the question is, all right, we can't make physical data centers. Can we make virtual ones? And this is where the whole concept of micro-segmentation became very interesting, right? The concept here, we obviously have servers, we have networks. Everyone is very familiar with virtualizing compute infrastructure. What the virtual networking essentially did was take advantage of the fact that for a number of years we've had these virtual switches on these virtual servers. And a virtual machine cannot connect to any other virtual machine or any other physical machine for that matter without passing through one of these virtual switches. And what Martin did at Nicira was create a network controller that takes control of all those virtual switches to create a virtual fabric, an overlay on top of it, which allowed us to say, listen, you can have physical networking underneath it, right? Network virtualization doesn't get rid of networks, just like server virtualization didn't get rid of servers. What it does is it takes the control plane part of it, what machine should be able to connect to another machine, and separate that from the actual physical infrastructure, network infrastructure underneath it. Because arguably, that control logic, that connection logic, it really has to do more with the application than it has to do with physical networking. And so now I can say SAP, which is this collection of machines connected together with the following network constructs, right, can be implemented irrespective of what hardware is underneath it. And I can do that in a virtual sense, creating these virtual data centers, if you will. And the whole conversation about micro-segmentation is really driven at enabling this kind of construct. And it's extraordinarily powerful, because it's not just a barrier, it's a policy primitive. It's the ability to say, here is the structural context of this application in a single place. All right? I can now do things like demonstrate the security posture of this. What is my security posture about SAP? What controls and policies do I have on SAP right now? It allows me to align my investment to risk. Right? We often have this dialogue about whether security is an insurance sale, right? I've commonly seen the ROI on security being you have a chance of big cost, and here's your investment. I would argue it's actually not that at all, or shouldn't be. It should be a risk management discussion. We're going to spend what we're going to spend. Are we spending it in the right places? Should we be spending it more protecting SAP? Should we be spending it more on this other area? But you can't have that if you can't expose the application and the structural context of the applications, right? So it allows us to do that. It allows us to align controls to it. It allows us to align controls to each other. And of course, it does allow us to isolate, to compartmentalize risk. So it's very powerful. I actually don't think of it as a firewall or in fact, it's more than just firewalling in order to implement this, right? There are plenty of powerful firewalls from the checkpoints and the Palo Altos. What we're trying to do is create a means of providing this means of aligning controls to what they're ultimately protecting, so that this commingled set of applications sharing this common infrastructure become these separate components that are isolated by default. It's a least privilege model, a zero trust model. And then we have a conversation of where does it need to explicitly be allowed to connect or structure security controls in between them in either a chain or a structured chain around certain assets. Suddenly this is possible. How does this actually work? Well, you all have the security controls that you know and love in almost any category. What we're really doing and through network virtualization is saying, look, first, we're going to provide the means of micro-segmenting this environment at an L2, L3 distributed firewall kind of capability. And then once you now have the micro-segments, now you have the ability to insert security services at a particular point in a certain order on the network or on the machines inside. Now I can say, here's SAP. What kind of controls with what kind of policy sets have to be on the perimeter of SAP, or between the web tier and the app tier of SAP, or on the endpoints within SAP, and suddenly that is possible. And when I'm dealing at an analytics level I'm under attack, I'm seeing things in far greater context. It's not a needle in a haystack. Suddenly I am dealing with a lot less information. The signal-to-noise ratio is tremendously improved in this kind of environment. The last thing we're doing, though, is we're leveraging our position in the hypervisor to surface context from the endpoint itself, the endpoint being the server, the virtual machine, and sharing that context with the network control, not just endpoint controls. And that's extraordinarily powerful, and I'll give you a good example. A number of you use virtual desktops as a security mechanism. You have contractors. You don't want your contractors bringing their laptops and connecting into various things in your data center. So you offer them a virtual desktop they connect to, and that connects. Great. You're going to implement security, of course, at the application and access layer, which means that you have authentication and authorization only to certain applications. How do you implement that and enforce that same policy at the infrastructure level? Right? And the way you would do it is to say, I leverage the identity of the user from what compute virtual machine they're logged into, and I pass that context to the firewall so that the firewall can have a rule that says if you're in the contractor group, this is the only place you can go. Now you have a control at the infrastructure layer and the application layer aligned to a single objective and to each other. When I often ask security teams, how many of the security issues you've faced are because you didn't have the right product versus you had an issue of misconfiguration and misalignment, those are far more common. What this does is it takes the fantastic products that you have and imbues them with new properties. They can be ubiquitous. They can be everywhere. They can have far richer context than they had. They now have the ability to leverage the infrastructure to mitigate. Controls can say, hey, I want the network to quarantine this. I want the network to remove remote access. I want the network to help me increase logging or retain logs for longer periods of time. It opens the door to leverage the network itself to mitigate. It provides a means of isolating themselves from the attack surface. And it allows orchestration between controls. One control can say, I've seen something highly suspicious. Any other security controls can take advantage of that analysis. Right. So, in summary, it's a changing, our perspective is the biggest issue we're facing is that the battlefield has changed and that what has happened is an inability for us to align controls. That explains, while we've had record investment, we still have had a pretty significant decline in effectiveness on security. That it makes a lot of sense that that is fundamentally the issue. There's an opportunity with virtualization, not just to secure the virtual layer, but to leverage the virtual layer to secure things, and this is precisely the very, very beginning of this. Let me give you a peek into the future in a few areas. I'll start with, and I apologize, I don't know how many folks were in the session that we did this morning on the keynote, but one of the next services, we're starting to now build a series of services on top of NSX and on top of ESX that leverage the sort of gravity-defying properties of virtualization to sort of reimagine certain security services. And one of the first ones that is currently being built, in fact, I have the guy running the engineering team right over there, is distributed network encryption. And really what that sort of, the problem it has been solving is we've been talking about this, I'm sorry, I'm pointing down and I should be pointing here. We've been talking about how the application is a network. And the issue we have on this network is how do we protect the confidentiality and integrity of the data as it moves across this network? And this is particularly problematic as we deal with stretched networks or things that are going side to side. I mean, encryption really hasn't been used internally for two reasons. One, there was a huge assumption that anything behind my perimeter was safe and was pretty trustworthy. I don't think there's any of us that believe that's true anymore, but that was a key assumption. And the second was that it was an extraordinarily painful task to manage encryption internally. Right? Dealing with network encryption, you have to go and how do I manage keys at the various termination points of each link, and how do I align these things together, and my policies have to do with encrypting traffic from this application over the network. That's a nightmare. So this has really been the fundamental issue that we were trying to deal with, and the ways we're implementing it by appliance, by agent, was problematic for these three main reasons. One, you had these bottlenecks as you hairpin traffic through that, or you dealt with agents that you were doing on it. The second is that you have this huge explosion of keys that you have to manage. And the third but not least is breaking visibility, including visibility of security controls themselves, right? So one way to break a firewall or an IDS or any of these products is to encrypt the traffic, and they can't actually do any inspection on the traffic itself. It's a problem. Okay, and really what we did is turning this into a distributed service. Distributed service really has a couple of fundamental properties. One, it's everywhere, right? You're distributing the processing across all of the nodes throughout the environment. But more importantly, I mean, I could make the same argument for taking a software-based firewall and just making copies of them everywhere. The key difference is to manage these as a single logical unit. It's as if it is one giant thing with infinite capacity that you're writing everything, so I can conceptually manage this as a single logical entity. And so by embedding encryption into the switch, placing it in all these virtual switches, much like we've done with the distributed firewall, and then managing this as a single unit, we open the door to do a bunch of things. Because it is everywhere, because we are distributing processing, because we are leveraging the crypto acceleration of the Intel chipset with AES-NI, we don't have the same bottlenecks, and we have pretty decent performance. Because we're encrypting and decrypting on the VM boundary, at the VNIC level, the application actually has no idea the encryption is happening. You don't have to alter the application. And I think the most compelling thing about it is that we're leveraging the network controller, right? The central brain behind network virtualization, and your definitions of the microsegments to inform us of who should have keys and how do we manage those keys, right? If you've just microsegmented SAP, or if you've microsegmented your PCI zone, your PCI scope, we now know all the systems that should legitimately be able to talk to each other, and we now know all the security services that need to be able to inspect the traffic going into that. We just provision the right keys and manage all those for you. And so encryption really can be a checkbox on the microsegment or the application. It could be extremely compelling, and it will work site to site. It will work across a stretched network, right? You're not implementing VPN tunnels across these. Really, really compelling. And it's innovating around simplicity and allowing us to focus on ultimately what we're trying to do. So that's distributed network encryption, and that's something that's being worked on now. We're very, very excited about that. The second area is, I think I've sort of talked through is, one of the things that this should be able to do is really enable us to have workloads of different trust levels share an underlying infrastructure. That's been a big issue, right? Think of PCI, or where I have a PCI workload on this machine. If I commingle it with workloads that are not PCI, I have to get all of them up to PCI scope. In fact, I'm dealing with a client now that is grappling with a PCI auditor that's come in. They failed an audit, and their entire network has been put in scope. Okay, well, that's bad. So how I find the ways to limit that, how I can reduce scope, and then furthermore, not in the process lose my ability to share utilization of the infrastructure by commingling workloads of different security levels is really a big deal. All right, distributed network encryption. Let's move on to the compute side. Another one of my team who's also probably here, Amit, I don't know if Amit's in the audience. Oh, there is Amit. He runs the engineering on that piece of it, is dealing with how we rethink and do new services on the compute side. And this is really interesting as well. As I said, the endpoint is a great place to do security and a lousy place to do security. The way we tend to do security on the endpoint, where we have on a virtual machine or a physical machine, we have an app and an OS, and we place an agent on that machine. Okay? That has stood us well, but one of the issues is now we have a lot of agents on a lot of machines, and we have to manage those through independent consoles. And there have been sort of companies that have tried to tackle some of this issue. I like what McAfee did with EPO and trying to sort of reduce the type and get some more sort of global visibility. There's a bunch of interesting things that have happened, but it's still an issue of how I manage that complexity. The second issue, which might even be larger, is that I do have rich context on the endpoint, but not all the context that I need. Some of the context, like topology. I mean, if an application now is a network and not a single executable or process, actually knowing the structural context and the fact that I'm not just an independent application, but I'm part of SAP is actually pretty damn important. So is provisioning context. What was I set up to be initially? Right? When the attacker is on the endpoint mucking around with the process names, the application names, knowing what quickly that telemetry becomes non-authoritative. But my provisioning state is authoritative. This is what I was originally set up to be. Knowing that there's a compensating control on the traffic stream just north and south of me is important context in the endpoint, but I tend not to have that. The third issue goes back to what I was describing earlier, which is this isolation property, because if I can compromise the OS or the application, I almost certainly compromise the agent that's inside. And then all bets are off. And any security solution that I can't trust when I'm under attack is questionable. And this is one of the fundamental issues we're dealing with on endpoint security. So what we tried to do is really leverage our position in the hypervisor to say, look, we actually have a reasonably isolated environment with the hypervisor kernel. Because in the hypervisor kernel, we've created a software environment where we have fundamentally taken control of address space, of memory, of the CPU. So we have control of those pieces. We can keep things separate. And we're actually relying on hardware primitives in the Intel chipset to enforce those boundaries. Now, that allows us to separate and isolate the kernel from user space. But in user space, all bets are off. It's like any other machine. Virtual machines get compromised all the time, right? It's much like any other type of machine. So the question we asked ourselves was, could we create a trusted execution environment inside the guest address space, leveraging our trusted piece? It's almost extending, much like a TPM, extending our trust from the hypervisor up into the guest address space. And so what we've been sort of building is this module inside the kernel layer, which establishes a trust level inside the kernel. It has a secure communication path to a monitor that's at the sort of OS address space inside each of the virtual machines so that we can guarantee the integrity of that. And it's from that vantage point that we're able to run trusted code and to monitor critical data. So in the first instantiation of what we're building, we're going to be able to not only run trusted code and monitor process, et cetera, we'll also be able to monitor critical data, meaning there are approaches and techniques that attackers could necessarily go to change certain things, but not without us knowing. So what we can say definitively is this machine was set up to be this, or this is this telemetry, or you know what, I am no longer a trusted state. All of which are incredibly compelling at sort of changing the battle space here. And so what this is going to provide us is an inability to turn the camera off, an ability to be able to preserve and monitor critical and sensitive security-related telemetry and data, to know when, to also know when we can no longer be trusted because someone is mucking around with the system and the environment. And it opens up all new possibilities. We have very rich telemetry that we can get at, that we can work with our security ecosystem, that there is stuff that we can do on top of that to guarantee sort of guest integrity. It will allow us to rethink many techniques around rootkitting. It will allow us to rethink a lot of behavioral analytics working with our ecosystem. It allows us to do some very, very interesting things. And of course, using a layer that is now touching 80% of the world's servers. So that's what we've been sort of working on under Project Goldilocks. Lastly, one of the areas that also being explored is sort of leveraging orchestration to the next level, right? Today, we are doing service insertion, the ability to service chain security products and security services into this environment. But that's really only the beginning, because it opens the door. Once you understand topology, where the security products are, what policy sets are deployed on those, to really be able to provide a view of security posture in a way that we simply couldn't before. To provide the means to automate workflows the way we simply couldn't before. DEF CON was something, it's codenamed DEF CON, is something that we sort of been tooling around for a while. The concept actually came, a bunch of us, Dennis Moreau over here, happy birthday, Dennis. Dennis's birthday today. Dennis is sort of our CTO on the security side on VMware. Dennis was also with me from RSA, and Chris over here was also there. And so when we were dealing with the breach, one of the things that the security team was doing was a systematic ratcheting back of access control into the environment, right? And the first thing they do is they kill Facebook and Gmail and eBay traffic, largely because you're trying to reduce the noise. And then the next thing you want to do is you're removing remote access into certain points and starting to enforce where you haven't necessarily before enforced certain authentication regimes into certain places. And you're increasing logging in certain areas. You're ratcheting that back up. What you can't do is just pull the cord on systems, because if you don't deal with the campaign, all you've done is you've informed the attacker they're now caught, and they are just switching channels to something else and you're blind. So this is very, very tricky work. And so The challenge with that is the time to think through all the things you got to do and the collateral damage those are going to cause is not when you have the FBI, the NSA, legal, the board of directors calling on the phone, all in the SOC at the same time. That's something you want to think up in advance of how you want to do it. Now, it's very difficult to orchestrate that kind of process in a traditional data center, but it's not that difficult in a virtual one. And so that opens the opportunity to innovate there. And then more holistic policy management around encryption is another example. So when I was talking this morning in the keynotes about what we're doing on VM decay encryption, the notion of being able to do all that through the lens of the application becomes possible. So, call to action here. I think it's the most exciting time to be in security, not just because of all the craziness that's going on, but I think actually we're on the cusp of making together very, very big breakthroughs in security here. And again, if you take away anything from this talk, this notion of how you align controls in the right place is something, the most fundamental thing. I think if you're just implementing controls, you're missing a huge opportunity. I don't know that you could actually solve the problem without thinking through that. But as practitioners, we have to get smarter about this. And my one urging to the folks who are practitioners in the audience is get educated on this and don't think of it as just how do you secure virtualization, but how you're going to use virtualization to secure things. It's a great opportunity for perhaps the first time for security to be a first-class citizen thinking about this as we're architecting our environments rather than the afterthought. The call to action on the infrastructure side, because VMware is not the only virtual infrastructure company, is to take this very seriously and offer these tools and open things up to the ecosystem here. It's too important for us to try to solve just in one place. This has to work across the Amazons of the world. This has to work across all of our clouds. And to the security vendors, the real call to action for those who haven't engaged is imagine how your products could benefit and evolve if they could be everywhere. If they could have the context of what's happening in the environment, application, the structural context, if they could leverage the infrastructure to mitigate, if they could isolate their position, if they could orchestrate with other controls, and take advantage of this. So, with that, I have done the impossible. I've done 51 slides in 40 minutes or 45 minutes. Everyone said that was impossible. I am happy in the last 12 minutes to take any questions and redirect the hard ones to VMware people in the audience. And we have, I think, microphones in the aisle, just so everyone can hear. And actually, some of these are being recorded for posterity. So,
Hi, Jeffrey Coulter, VCE. What are your thoughts on timelines for availability for the upcoming projects that you mentioned?
Oh, God, the one question that legal is going to be down my throat on it. The stuff that I've been talking about is coming out next year. To go into more detail on it, I can't, unfortunately, because I have a legal team that will come chasing me down the hallways, but it's being built as we speak. Right?
Hey.
Yeah.
Could you comment on what Bromium is doing and how that contrasts with like Goldilocks?
What Bromium is doing? All right, well, I don't want to speak all for Bromium, but Bromium is really providing sort of a microvisor at a sort of a user endpoint level. It's actually a very interesting concept of saying I'm going to divide up my endpoint into a series of virtual machines. I can separate the machines, sort of a red zone, green zone concept. That the notion being that if I'm opening a tab in a browser, I can isolate that to a separate microvisor and not. What we're talking about here, there's a similar concept, but what we're talking about here is more a data center concept. A Bromium, again, I'm not an expert in Bromium, but a Bromium typically isn't used in a server context. It's really more used at an end user device context. And no math questions? Train leaving Chicago, 4 a.m., traveling south? Yes? So the question is, what strength of encryption are we doing? The Donald Trump answer is very strong. No, good enough. I think AES one, we're having two flavors. I think initially AES 128 and 256, and then we're going to be making it after the first version pluggable so that you can create your own, plug your own algorithms into it. Yes, sir. And the question is, any persistent authentication, like SHA hash? OK, this is one of those questions I will deflect to. Who wants to take that one? I have a perplexed look. I'm sorry? So what type of authentication? You're talking about the machine-to-machine authentication, and whether we're using SHA hash, or what's the mechanism of authentication, if you want to get a microphone, or I guess it's sort of getting at to the authentication mechanism for the VM-to-VM encryption. And now Azim will present a PhD dissertation on our.
Sorry,
doing code reviews in the front.
I'll do a simple answer. It's just symmetric key encryption, AES 128 or 256 GCM.
There's no complementary hash in addition to the AES.
Oh, so in cases where we don't want to do encryption, if you just want to do integrity, we just add a hash at the end of the packet.
So actually, we'll also, I mean, a number of us will be here afterwards if you want to go into detail. Yes, sir. So the question is the VMDK encryption different from this? It is. The VMDK encryption is being implemented at the hypervisor level. The VMDK encryption, of course, is the data at rest piece. You're not encrypting a link. So what the D&E encryption is doing is, if you take SAP, all these machines that are networked together, at the VNIC to VNIC level of that system, we're doing encryption, authentication, and hash integrity checking on each of those links that occurs in, right? And the VMDK encryption is essentially when the VM is at rest, it's encrypting that VM. It has sort of an envelope encryption process that essentially will encrypt the key, and then the key will be decrypted from a central external key management server, and then that key will be used to decrypt the VM. And what that allows us to do is a few things. It allows us to, first of all, because we're encrypting at the hypervisor data level, it's agnostic to the OS and the application above it. You're not dealing with managing agents everywhere. It also allows us to encrypt in one place but run it anywhere. So you can encrypt it here when it's at rest, and then you're moving that VM up until the cloud. And then when you wake up and run that encryption, it can decrypt there. So it's slightly different.